Hello and welcome to lesson 32 of the addition and subtraction unit. My name's Mr. Coombs and I'm going to be guiding you through your learning today. If you haven't got a pen and pencil and a piece of paper and the practice activity from the end of the previous lesson, pause the video, go and get them now. Otherwise, let's begin. Let's start by looking at the challenge question from the previous lesson. We were told that both the lawns had the same perimeter. And you were asked to think about how long was the side that was marked X. And you were also asked to try and think about more than one way of how you might go about solving that question. You then had to try and reflect and decide which was the most efficient method. Which way did you prefer to solve it? Well, I'm going to go through two different ways that I think made it a really efficient way of solving this problem. Did you find the whole perimeter? That's fine if you did, but the way that I'm going to explore takes a lot less calculating. Can you notice how I've labelled the shapes to make it clearer as well? Remember, it's always a good idea to annotate questions or diagrams. It can really help. You have to be confident in your understanding of perimeter, but as we know, the length add the width times by 2 would give us the perimeter for both of the shapes on our screen. We just need to concentrate on how we can balance this. So we're going to focus on balancing the length and the width, which would be half the perimeter. And if we do that correctly, this would automatically mean that the whole perimeter was also balanced. If we use the idea of a balanced equation, we can start to see how to solve this. I have all the information that I need for shape A. 37.44 add 87.36 would give me the length and the width, half the perimeter. And I know that that will be equal to the length and the width of shape B. But I only have one of the lengths for shape B. So if I bring this information together, I can still form a balanced equation. 56.16 add X. Now that I've got my balanced equation, I'm going to be able to start to work things out. Let's start by looking at shape A. 37.44 add 87.36. Remember, it's about you finding the most efficient method for you to answer. It might not be the same for everyone, but hopefully, whichever method you used, you would have got 124.8. So now we know 124.8 is equal to 56.16 add X. Now, how do we find the missing value? Well, we'll find the missing value by getting our 124.8 and subtracting the 56.16. That will give us the value. I'd like you to pause the video and just answer that question. How did you get on? Did you use a column method? It wasn't as straightforward as it might have been, was it? Well, I'm sure that we all got 68.64, which means we have successfully solved the problem and identified the value of X. But what if there was an easier way that avoided that last tricky subtraction calculation? Because we know that the length and the width of shape A has to be equal to the length and width of shape B, we can use the idea of the same sum to help us solve it. If we look at the add end on the left and then an add end on the right, we can see how much it has been increased or decreased by. Now, if we use that change to increase the second add end, we will find the missing amount in the expression by balancing the equation. We will find the value of X. I think you would agree that this calculation and the one above looks a lot more straightforward than the other. We can get the length of X and we have now balanced the equation. How did you do that? Would you do that mentally rather than relying on a formal written method? Remember, there is always more than one way to solve a problem. The skill is to reason which is the most effective and apply that understanding into similar problems in the future. What do you notice about this equation? Now, the numbers are deliberately easy to calculate, as I want you to concentrate on the expression on either side of the equal symbol. Did you notice that there are different expressions on either side of the equals? One was subtraction and one was addition. In the previous lessons, we've only been looking at balanced equations that involve the same type of expression on either side. Does this matter, do you think? Well, if we apply our understanding of balanced equations, we can remember that STEM sentence. The value of the expression on each side of the equal symbol must be the same. Then we understand that it doesn't matter, as we just need to concentrate on the value of each side and make sure that value is equal. These equations are balanced. Is this statement true or false? I want you to pause the video and decide whether the equations are correct. Are the expressions balanced? Investigate each one, working out its value. Remember, you can use whatever method you want to do this. It's about using whatever is best for you. Have a go. How did you find that? Are you starting to feel a little bit more confident? Excellent. Let's start by looking at the top equation. The expression on the left is subtraction. 76 subtract 32. We know that's 44. The expression on the right is an addition expression. 19 add 25 is 44. So that equation is balanced. That was true. Now let's look at the bottom one. 22.2 add 22 is 44.2. And 56.5 subtract 12.5 is 44. We can see that this isn't balanced. This is what the not equals symbol looks like in mathematics, but we could take it a step further. We could use our inequality symbol to say that 22.2 add 22 is greater than 56.5 subtract 12.5. How might you have spotted that this equation wasn't balanced straight away? Have a look at the decimals involved. On one side we have 2 tenths. Add 0 tenths, which will mean that we still have 2 tenths. And on the other side we had 5 tenths subtract 5 tenths, which means we'd have 0 tenths. Always try to look to see if something jumps out at you as being wrong. It might save you a whole lot of calculating. It's always worth looking for those connections that might make things easier for us. Let's have a look at this question then. Jessica says that she knows that 49,000 add 5,000 is equal to 100,000 subtract 46,000. She then says that because she knows this, she must be correct in saying 48,000 add 5,000 is equal to 100,000 subtract 45,000. I want you to think about whether Jessica's statements are true or false. I want you to pause the video to find out if she is correct. And remember to prove your answers. How did you get on? How did you prove it? Well, let's look at the first one. 49,000 add 5,000 is 54,000. And then 100,000 subtract 46,000 is 54,000. Did you use your complements to 100 to answer that subtraction? I know I did. The equation is balanced because the value of the expressions on each side of the equal symbol are the same. Look at the second equation. This is not balanced because the values are not equal. Let's put our not equal symbol in there. And again, we can use our inequality symbol to correct this statement. 48,000 add 5,000 is less than 100,000 subtract 45,000. Why do you think Jessica got this wrong? Did you spot her mistake? I want you to take a moment now and look at the two equations, and I want you to think about what's the same and what's different about them. I'm sure something's jumping out at you. If we have a look at the first one, the first thing that jumped out at me is that one addend has decreased by 1,000 and the other addend stayed the same. So that means that the total will also decrease by 1,000. On the other expression, the whole has stayed the same and one of the parts have decreased by 1,000. This means that the other part will need to increase by 1,000 so that the whole stays the same. Now, notice how I used the term whole and part there. That made me think about my part-whole models. Well, if I had 49,000 and 5,000, my whole would be 54,000. Now, in the second calculation, it changed to 48,000 add 5,000, which was a decrease of 1,000. And that means my whole, my total, would also need to decrease by 1,000. On the other expression, we had my whole, and we had that one of the parts was 46,000. This means that the other part for this was 54,000. But when Jessica changed the calculation, she said 45,000. That's a decrease of 1,000, which actually means my other part would need to increase by 1,000 in order to keep the whole the same. Jessica has used the wrong compensation. If one addend in the addition expression is decreased by 1,000, to balance that equation, the subjugend in the subtraction expression would actually need to increase by 1,000. Let's go back and look at that first balanced equation that I showed you. How could we put this into one part-whole model? Well, I thought about it and I actually thought, let's do it bit by bit. So the first calculation tells us we've got 10, we subtract 6, and that's, well, I don't need to know what that is. I just need to know that that is equal to 3. Add 1. Can you see how I don't need the value of the question mark, but seeing that 10 subtract 6 is equal to 3 add 1. That question mark has the same value. And because the numbers are simple, we know that the question mark would be 4. 10 subtract 6 is 4. 3 add 1 is 4. We just need to see that relationship between them. It's just helping us to see the maths and the relationship between the two expressions on either side of the equal sign. Now, part-whole model is one way, but how else could we represent this calculation? What did you decide on? I thought that a bar model might be another good way of showing this, so I started to fill it in. And I quickly realised that actually, again, it was the understanding the positioning of that question mark that was key to finding whether the equation is balanced. Although we don't need to know what the value is, we do need to understand that the value of that question mark is the same for both expressions. Now, I also realised maybe it's quite important to understand that it doesn't matter which order those expressions are shown in, whether it's a subtraction or an addition one that comes first. It's just the value of the whole expression that matters. Using our new part-whole model, we can fill it in for Jessica's calculations. Notice how I've displayed the balanced equation with the addition first and then the addition coming second, in order for us to realise that it isn't important. Again, we don't need to know the value of each expression. We just need to understand that the value is equal. If we understand this, then this model and this structure really helps us and would really help us in the future when we start to solve trickier questions. I know that you've already worked out the value, but it's always good to see it. So I fill my 100,000 in, and I knew that one of the parts was 46,000. And I knew that that part, that question mark, was the same value as what 49,000 add 5,000 was. Now, whether you use your complement to 100 to work out this subtraction calculation, or whether you just added the 49,000 and the 5,000 to check that the values were equal, it's good to know that you can do either or both in order to make sure that you are correct. Let's look at the one that Jessica miscalculated because she used the wrong compensation for the second equation. We can see that if we start to fill in our model, then the question mark should be the same for both expressions. But we can quickly see that 100,000 subtract 45,000 equals 55,000, and 48,000 add 5,000 is 53,000. So we can see that they are not balanced, they are not of equal value. So we can put our not equal sign there, but we know that we can take this a little bit further because we can use our inequality symbol to correct them. We could say that 48,000 add 5,000 is less than 100,000 subtract 45,000. So 100,000 subtract 45,000 is greater than 48,000 add 5,000. Now that we're starting to understand how we can represent our balanced equations, let's make sure we are confident at looking at the connections and seeing what's the same and what's different within a group of equations. We can use this understanding to correctly identify what's happened in order to correctly identify whether they are balanced. Well, we know that if one addend is decreased by 1,000, the subtrahend would needed to have been increased by 1,000. Use this understanding to answer what would be the missing subtrahend of this calculation. Well, again, the addend has been decreased by 1,000. The subtrahend would need to be what in order for it to be balanced? Yeah, well done. It would need to be increased by 1,000. We can use this knowledge to really quickly understand and solve the problem. We would know that the missing subtrahend should be 48,000. Well done. Now let's try and look at a real life context. We're going to put this information into our model. We've got Emma. Emma had £50 and then bought a new toy for £15. If we were to put that into the part-part whole model, it would look like this. But what we don't know is how much she's got left. Let's carry on our story. Louis had £10. I'll add that to the model. And then he was given an extra £25 for his birthday. Now Emma and Louis have the same amount of money. That's what the model is telling us. 50 subtract 15 is equal to 10 add 25. Do you think that you would be able to write a balanced equation for this story? Remember, we're not trying to find out how much they have. We're just trying to see the maths and understand that they have the same amount of money. Have a go now and see how you get on. The balanced equation would be this. £50 subtract £15 is the same as £10 add £25. And remember, because we are confident with this model, you're going to be able to use it to find out missing information in different stories. Let's have a look at another story then. Caleb had £2.34 in his piggy bank. He then found 33p in the sofa. George had £3.66 in his piggy bank, but then he went and spent 99p on a magazine. The important information: Caleb and George have the same amount of money. Your challenge is to pause the video and write a balanced equation for this story. Try and prove it by putting it into the part-whole model or the bar model. Have a go. How did you find that? Well, I always try to put the information into a bar model or a part-whole model as I get it. So I started with Caleb, and I knew that he had £2.34 in his piggy bank, and then he found some money. So his amount of money is going to increase by 33p. So I put that in to the part-whole model. And then I put my question mark there because I don't know at the moment how much he has. But remember, I don't need to know. All I need to know is that it is the same as what George had. George had £3.66 in his piggy bank, and he spent 99p on a magazine. So if you're spending money, the amount that you have is going to decrease. So I put the amount he started with, and then I put the part that he spent. That would leave me with what he was left, that question mark. So I can now put that into a balanced equation because I know that Caleb and George have the same amount of money. My balanced equation would look like this. If we didn't have all of that information, you would still be able to solve a question about that story because of our understanding. For example, if I didn't tell you how much Caleb found in the sofa, you would be able to see how you could discover that from finding out what George now had and then using that to find out how much more he needed to reach to get the same total. As I've said, seeing the maths, understanding what is happening is so important. It's not just about giving us the answers. Sadly, we've reached the end, so here is your practice activity to complete ready for the next lesson. Can you create a set of related balanced equations because you know that 50,000 add 25,000 is equal to 150,000 subtract 75,000? Think about how a change to one of the expressions requires a change in the other expression. I think you've done really well, so I've set you a bit of a challenge. Are you ready for a challenge? I want you to use the bar model and the part-whole representation to create a balanced equation. You will notice that there is more than one missing value, so it will really make you think. Try to write a story about the information that is represented and then have it ready to go through in the next lesson. Good luck. Thanks for joining me, and remember, the value of the expression on each side of the equal symbol must be the same. That will really help you. Goodbye.